All right, first and foremost, I am recording my lectures. This is just something that started because I would be simultaneously teaching this to the students who were studying in the Temple, Japan campus. By the way, there's a campus in Japan, so incidentally. And I just started recording my lectures out of habit so that I can throw them online for you guys to review. Just letting you guys know, because I'm not sure what the recording laws are in Pennsylvania, but generally assuming that's two-party consent is generally the best policy. All right, so we're going to just do the standard starting with the syllabus, and then we'll jump right into our stuff. So the syllabus is online. Welcome to the course. This is 1051, which is Intro to Problem Solving in Programming in Python. So I put a big fat warning at the beginning of the syllabus that uttering some variation of the phrase, "I did not know we needed to demo our assignments to receive credit. After the first exam will be grounds for an instant F in the course." Do not use those words. That means basically that, as I'll get into, your homeworks have two parts. First, you have to turn your homework in, and then you have to show it to me or a TA, right? So just be aware of that. I'm not saying if you don't demo your course stuff, that's an instant F. I'm saying that if you somehow don't know this, because there's always just one student, and I'm tired of having to deal with that student. So maybe this warning will mean that there's no students this time. All right, and then we're using Python 3, not Python 2 for this course. That's not like anything like as shocking as the first one. All right, so this is CIS 1051. It is an introductory course for both people who want to become programmers and people who want to know more about programming. It is intended for people who have no knowledge in programming or maybe just a smidge, right? If you know about arrays and can write for loops, and if you know object-oriented programming, and if you know that stuff, then maybe 1068 might be a better fill for you. Or 1057, where you learn C, which is a very valuable language to know. So we want to give you, if you're a non-programmer and don't intend to be, maybe you're in biology or business, it gives you a sufficient amount of programming experience to apply programming techniques and be able to automate a bit of your job if you're stuck being an office drone or something. Or if you're a biologist, then basically being able to automate some tests. And Python's a fantastic language for this. So this is a 4-credit-hour course. This means that there's about 8 to 12 hours of work each week outside of lecture is expected in terms of like the calculations. Generally, though, that's not necessarily the case, like especially the first couple weeks. But the vast majority of your time, of that work time over here, is you banging your head against the keyboard going, "Why isn't this working?" until there's a simple fix that you realize that there was working, and then you feel really depressed. This is common. You are not stupid if you run into an issue that takes you 3 hours to solve and it was super simple. You are not stupid. You will think you are, but you are not. The difference between me and the TAs and the rest of you guys is that we've all made the error about 50 times, and this is your first time making it. So we're able to fix it because we've made this mistake a bajillion times. You're making it the first time, and you have to learn that problem-solving process all new. All right? Time and place is this place, Tuesday and Thursday. You found it. I don't know why I need to put this in the syllabus, because you found this probably by looking at the schedule, not at the syllabus. All right? Here are the labs. We added, so we have 1, 2, 3, 4, and 6, because somebody else has 5, and then we saw that there were still plenty of students on the wait list, so we added an additional section. So just be aware of that. The labs are on Wednesday and Thursdays, and the TAs will be there for the most, the TAs will be there to run the labs. You need a C or better in 1021, and I strongly recommend having a laptop just so simply you can use it. If you cannot afford a laptop, please let me know as soon as possible, because I generally feel that students over budget for their laptops. Unless you're like doing a severe amount of gaming, you don't need to spend like $1,000 on a laptop. If you're just using it for internet browsing and some basic programming, then you're probably good with a $300, $400 budget. So the resource and textbook. I hate textbook costs. I'm sure you do too. I went through great pains to find a good textbook that was pretty cheap, and also the text of it is freely available online, like by the author. So that is Automate the Boring Stuff with Python. It is not a standard computer science textbook, but it is a programming textbook, meaning that it's mainly focused on getting people writing programs and not so much on the theory of stuff. That's perfectly fine for this course. It's available here at this link, automatetheboringstuff.com, and you can get a copy of the textbook for like $30. It's relatively cheap compared to your other ones. If you need additional reference, you can look at Think Python, also another free programming book that's done in Python. And then finally, the Python documentation itself has some good tutorials if you get lost or want to see how somebody else wrote instructions for it. All right, so there is a good deal of stuff. Most of the stuff I'll be presenting roughly in the order of Sweigart's book, but some content like turtles, those aren't in the textbook. Instead, we'll find them on the Java documentation page, right? So my office hours, my office is in Circ 349. I have office hours on Monday and Tuesday to maximize my availability to you guys. Monday from 3 to 4 and Tuesday from 4 to 5, so a bit after this class. If you can't make it to either of those office hours, that's perfectly fine. I am available. These are just the hours where you can just walk in and see me, right? And I'll be available for you guys. So you can just walk in without making an appointment. If you want to, yes?
You said
Turtles.
turtles?
Turtle graphics. It's a graphic, so those are graphics that were designed for the Logo programming language in 1962, I think. And they're a very easy way to draw graphics. What you do is imagine you've got a turtle with a pen, you tell it to move forward and it drags the pen with it, and then you tell it to turn at angles. So it's a very easy way to draw shapes without necessarily trying to learn about pixels and stuff like that. It's a very easy way to kind of learn how to manipulate things with for loops. So it's a very good programming paradigm. Plus you can draw stuff with it, so that's cool. So Monday and Tuesday are Monday and Tuesday, 3 and 4 on those respective days. You can just walk in and see me. If you need to meet me at some other time, just send me an email and we'll coordinate a time. And I'm available most days I'm available at most times from Monday through Thursday. Friday is a bit tougher for me. And otherwise, if you can't make it to campus because you're have this horrendous commute, I can always video chat with you, because the internet's a thing and it's a wonderful thing and we should use it. So TAs, they'll be present during labs to assist you. I'm still trying to populate. I'll upload a new version of this because I'm still in the process of getting another TA. But these are their emails. There should be another TA, and the office hours are here. Notice that I did not say which section each TA belongs to. This is because, since it's the same course, right, you can just go to any TA you want, so long as it fits your schedule, right? It doesn't have to be your TA. All right? Executive summary of this is don't cheat. Expect a new lab or homework and a quiz each week. I'll be recording the lectures. Turn your work in on time. Don't ignore errors while you're coding. And it's okay to turn in errors. It's okay to turn in your work late. Demoing, you got to actually show us the work to get a grade. And exams are the most of your grade. But most importantly, don't be afraid to ask a question or ask for help. I don't think less of you for that. I'm not going to think you're stupid. If you have a question, then I guarantee at least 20 other people in the classroom have this question. So don't be afraid to ask that question. All right. Attendance, I expect you to come to the lectures and labs. However, if you're sick, please don't come because I don't need you to share your germs with me and my toddler at home. That's also part of the reason I record my lecture. So because it's stupid of you to just, it's really stupid to force you to come to class while you're sick when you're not going to really learn. Just catch up when you can, okay? So, but otherwise, I expect you to be here, especially since there will be quizzes, and if you need to miss the class, then just email me so you can make up those quizzes. Academic honesty. I want you to work with other people, but I don't want you to cheat. That means don't copy in other people's work and don't turn other people's work in as your own. Specifically what this means is that, just don't copy and paste code from the internet. We are able to we're pretty good at telling. And don't email your friend for code and just change a couple variables and then turn it in as your own. you know, I remember that a couple semesters ago, I had a student who posted one of my answers to you know, one of those homework help websites, you know, and he very kindly kept his student ID in the email, sorry, in the assignment. So, you know, it's not too hard, but some people make it easy. But don't cheat, don't copy work and present it as your own, but I do want you to work with other people. And part of what I do to make, and part of this demoing thing is to make sure you understand it, because we'll generally ask you a couple questions about your work. So if you do work with somebody else, we do try to make sure that you understand it, right? And when you work with somebody else, just turn in your own code. Don't turn in the same code is the main thing. There's a couple of assignments that we'll do that we bend the rules for that, and you can both turn in the same thing. But other than that, you know, you can work with other people. Don't be afraid to work with other people. Okay. When in doubt, cite. Just simply said, I worked with somebody else, because then it's not plagiarism, because you're not misrepresenting somebody else's own work as your own. So when in doubt, do use the citation. Disabilities. If you have a disability, I have to fix this because that's for Temple, Japan. But contact DRS, Disability Resource Services, and they'll be able to accommodate you, and they'll let me know what you need. All right. Grading. So grading in this class, generally you need a 70 or above to pass the class. The curve for classes like this, generally you get an A guaranteed if you get 90 or above. And then the A- range, let's see, like for 2168 last semester, that was 88 and a half. 88 and a half and above got an A-. So generally, like, I bend down the ranges so that you can to see what's the most fair thing. Generally, most people get A's and B's. There's very, very few C's. The DFW rate for this class and similar classes is across all universities in the United States is somewhere between 20% to 33%. That means that anywhere between a fifth and a third of the students, they fail the class or they withdraw. Generally, though, that's because they don't show up or don't try doing their homework. I do quizzes in class. They're going to be on Canvas, so they're going to be electronic. Hence, please bring in a laptop or a phone. You'll be able to use your phone for that. Also, some days we'll do in-class exercises, which will count as quizzes. And worst case scenario for those, if you don't have a laptop, most of those will be paired, so you'll be able to work with somebody else. All right. So compilation is more for the for Java, but if you have a syntax error and your program doesn't run, then that's an issue, right? Your program has to run. If you have an issue, read the check out chapter 0 of the textbook. It has a very good how to solve errors. But generally, reading the error and finding the line number, because it will tell you what line your error is on, is a good way to do it. Check that your parentheses or braces or brackets match. Use Google to find that to look up the error. Or email me or UTA. Email a Python file, not a PYC file. Don't submit a .txt, a Word document, or a rich text file. That's not what I need. I need a PY file. So how do you this demoing thing work? First, you submit your assignment online to Canvas. That's so we have an electronic paper trail for it. So you can say, I submitted it at this point, and this is what I submitted. And that will just simply lock it in as to when you turned it in. So we have a late policy for this class. It's 5% off per day, not 5 points, but 5%. That means that the first day is a 90, that is late is a 95. Second day late is a 90.25. We're also very, very fair about the way this late policy works. So if you have a assignment that has 5 parts and you turn in 4 parts and then turn in the 5th part late, the 4 parts you turned in on time will be graded at full credit, and that 5th part will be graded late. I try to be as fair as possible about this because I want you to do your work, and I don't want you to not turn in your work. I want you to turn in what work you have when you have it. All right? To actually get that grade, though, you have to demo it. Demoing your work involves showing the program works and explaining pieces of the source code and answering questions. So that can be done before class, during some class if we have some class exercises going on, after class, or during office hours. Also during the lab. The bid lab is also a big time to demo this. I wrote this for Japan, which was like this weird. I taught this in Japan in past summer, so this was I missed some of the things that I had changed for that class. So demoing your work is important. Yes.
Can you just leave comments in whatever program?
Sorry.
Can you leave comments in your program?
You can leave comments in your program. Yeah.
Showing your work or explain how it works.
Yeah, you can leave comments to explain how it works. If you're not comfortable like explaining your code, then you can leave comments, and that's usually a very good way to refer to it. Comments are pieces of code that are pieces of text in your code that your computer does not read. So it's useful for communicating with yourself and other people and reminding you, oh, what was this? I wrote this about a week ago. What does it do again? That's what comments are for. Exams. Makeup exams are given on a case-by-case basis. Please don't miss the exams. Generally, if you email me and tell me you're not going to make it because I'm sick, my car broke down, whatever, I have a wedding that day, I'm going to be cool with it. I'm going to be as lenient as I can with these things, right? Makeup exams, just let me know what emergency you have. They are about half your grade, so if not more. So don't miss them. I do provide. That said, I do provide practice exams to you. And essentially the way the practice exam is created is that I create 2 exams, and I give one to you and use one as the real exam. So they are excellent approximations. A lot of times I just simply change the numbers for a lot of questions, essentially. Some questions are just thematically similar. Or they're the inverse, like, you use A to solve B, and then this time, maybe on the exam, I'll ask you to use B to solve A, right? Those kind of things, those kind of deals. But I do provide you guys with the best chance for success as possible. There are 2 exams and a final, approximately at week 5 and week 10, and those take place in your lab period, right? So that you can have the maximum amount of time to work on it. Which would be like an hour and 50 minutes as opposed to the hour and 20 minutes you'd get in here. As far as the note policy, I gotta recall, it depends on the exam, but I generally put on the back of the first page a bunch of useful notes and useful functions for you to refer to. Like what would I bring in as my cheat sheet? So there's that. Final exam details, I have no idea what the final exam is going to be other than that I'm writing it. I just don't know where it occurs until much later in the semester. It is cumulative. Oh, yeah, there, I guess I say it. So for notes, you can bring in a single sheet of letter A4 or the comparable equivalent of paper, so standard size paper. You can use both sides, and you can put anything you want on it, so it can be handwritten or typed, right? So, right, and then the rest, of course, is your standard disclaimer. I have tips for succeeding here. You should read them. But essentially they say work on your homework because otherwise you're doomed. It's because, and this gets into an important thing because programming is a craft. It's an academic discipline. That means that basically that the only way you're really going to be able to succeed at it is practicing, right? At times you might be, again, I'm going to say multiple times, you might feel like really stupid about some stuff. That's okay. Essentially, you have to practice, and practice is the only way you're going to get better at it. A strong work ethic counts for more than you would imagine in this class. So, you should work on your homework, get started early on them, ask for help when you encounter problems with them. Especially since they're like 25% of your grade, so, it's a pretty good, decent amount for your homework. So let's go ahead and get started with some, history let's start with some history to keep this first lecture a bit light. So let's see. So how many people, by show of hands, have some programming experience? So a good number of students. All right, so if your programming experience has been in Python, raise your hand. So less students. And Java and C. Yeah, good number of students know a lot of languages, right? So, but if you don't know, don't worry. And how many of you just simply learned it on your own? A good number, too. It's not a particularly hard thing to do, learning programming, although, again, if you have a strong work ethic, it goes a long way. And I say this from experience. I had a trash work ethic as a freshman, and my grades suffered accordingly. It wasn't until my junior or senior year that I started getting into the dean's list and stuff like that. I was pretty terrible as a student. I was a B/C student my first semester. So that's my warning to you. Just, and the main reason for that is I didn't do my homework. All right, so what is computer science? So computer science is a terrible name because it's not really about computers. There's this great quote here that I like. Computer science is no more about computers than astronomy is about telescope, biology about microscopes, or chemistry about beakers and test tubes. Science is not the tools. It's about how you use the tools and what you find out when you do use the tools. It's not about the study of computers, and it's not programming, although it uses programming a whole lot. It's an understandable misconception because your first computer science class is going to be a programming class. And there's nothing wrong with that. It isn't about learning just programming languages because computer science did exist long before formal programming languages showed up, as well as there are now fields like graph theory that are now like shared between mathematics and computer science, but start out in mathematics. We don't study specific software. We come up with software to build and formalize it. So we can define what computer science isn't, and part of the issue with defining it is that we have a lot of there's a lot of arguments about. If you ask two academics, you might have three opinions for what computer science is. But everybody will say it's not wrong if we use the simple definition of computer science is the study of algorithms. That's your not wrong definition, okay? Everybody's going to go, yeah, I guess that's right. It's the study of how we automate problem-solving processes. It asks what exactly can be automated when we get right down to it. And what can be efficiently automated? What does efficient mean? Does it remain efficient at scale? Are these problems even possible to automate? Theoretical computer science covers a wide variety of topics, including algorithms, data structures, computational complexity, parallel and distributed computation, probabilistic computation, quantum computation, automata theory, information theory, cryptography, program semantics and verification, machine learning, computational biology, computational economics, computational geometry, and computational number theory and algebra. A lot of stuff in just one subfield of computer science. The big thing these days is bioinformatics, which is using computer science to solve biology problems. So basically hashing out particular DNA sequences to see, or RNA sequences to see what might be effective, seeing what kind of drugs might react to viruses in simulations, those kind of things. So it's very, very big. So computer science being the study of algorithms, since we haven't defined algorithms, what does that mean? We study algorithms to determine if they're correct and efficient. In other words, do they solve the problem we want them to solve, and do they do it well? Designing computer systems that are able to execute these algorithms. In other words, the hardware, basically, the thing I'm using to project onto the screen. So algorithms are these processes for solving problems. So we study those. We study the way to build systems to solve those problems. We design programming languages to translate those algorithms into instructions our machine can understand. And then we also identify important problems and designing correct software packages to be able to solve those problems. There's a lot of things besides being a code monkey computer science is good for. As I mentioned, bioinformatics, using it in biology or chemistry or medicine is big right now, because you can do stuff like cancer detection and design new medicines. You can use use it to create HIV inhibitors. You can use it to design prosthetics, right? Because those are, advanced prosthetics use robotics. That's kind of an easy correlation there. Physics and astronomy, you've got quantum computing right around the corner. one big thing in astronomy right now is using computers to detect supernovas. Most of those are detected automatically, are detected using automatic systems these days, and analyzing particular, waveforms. There's a ton of astronomy data. The Large Synoptic Survey Telescope is expected to gather 440 terabytes a day, 140 terabytes of data a day. Engineering, business and economics. One big one is high-speed trading algorithms. That most of Wall Street, right, is automated these days, right? If you go down to the New York Stock Exchange, it's essentially a TV set at these days. Not much actual buying and selling goes on there. Most of the buying and selling is done by algorithms and trading bots. Psychology, there's an entire field dedicated to computers and psychology called human-computer interaction. That's where I got my start in research, and that's about like how do humans use computers? How can we make computers frustration-free? At what point do people get frustrated with computers? How can we actually use them to make our lives better? One thing that's interesting is how do you make user interfaces and acoustical maps for blind users? And of course, education. Can you make entertaining educational software? Can you make good games that teach people stuff? So what is an algorithm? So algorithm comes from the Latinized name of Muhammad ibn Musa al-Khwarizmi. I probably butchered the pronunciation of that, but that got Latinized to algorithmity. He wrote a textbook called that, and the title of that translates to the concise book of calculation by reduction. And he wrote that in 820, and we get the word algebra from which means reduction, from its title. So you can blame him for your algebra classes. There you go. That's the guy. He also wrote a book on how to handle these newfangled base 10 digits, the Indian decimal system, and that eventually got translated in the 1100s, and that spread throughout Europe. So from algorithmity, we get algorithm. So the formal definition for algorithm, it is that it is a well-ordered, unambiguous operation that yields results in a finite amount of time. What does that mean? They're well-ordered, meaning the instructions that happen occur in a specific order, right? You have step 1, step 2, step 3, right? Step 1, turn the oven on to 350 degrees. Step 2, combine the ingredients. Step 3, put batter into oven, right? A good recipe is an algorithm. Unambiguous operations. It's not enough to just simply say that thing. You got to be able to actually specify what the thing is, right? Unambiguous operations. Your computers don't like ambiguity. They want precision. Right? I'm sure you've seen all those those things on Facebook, like that's a math puzzle and says, oh, only 5% of people can solve this particular math problem that deals with orders of operation, and it has to do with the fact that some orders of operation are actually ambiguous. So, computers don't like those problems. They like to translate everything into a different mathematical notation, which is unambiguous, postfix notation. So they yield some result. In other words, they give you an answer, right? You just don't run them, you don't just run it and it does nothing. That's boring. And they yield a result in some finite amount of time. It doesn't go on forever. The execution will end. Now, it might not end while you're still alive, but if it ends, there you go. Generally, we'd like it to be done, within a reasonable amount of time. So let's go ahead and take a look at what our programming language. So we are working in Python. Now, Python is a very popular programming language, but that's not the reason we particularly use it. We don't use stuff because it's popular. We use stuff because it's good. Also, there are only two types of programming languages. There's programming languages people complain about and programming languages that nobody uses, okay? So every programming language has its own problems. I love Python. I did my dissertation in it. It's my favorite programming language. However, it has some issues, and there's things that could be better designed. But every programming language has those things. To get Python, go to download. It will identify your system, and you'll be able to install it there. You'll want to download Python 3 for your computer. If you're using a Mac, you'll want to download the latest version of Python from the Python website, even if you've got Python already installed. And you'll want your Mac to be at least at Mac OS 10.6 for later in the semester when we deal with turtles. But we go here, we'll download this, install it, follow the instructions, and it will install Python onto your system. All right. Now, the first exposure to Python is going to be through the idle shell. Now, idle is looks like this, and it will be installed on your system with Python. It's the primary way you don't have to use idle, by the way. If you've already got a programming tool you like Vim, Emacs, PyCharm, or something like that, use that. I'm going to use idle a lot of the time because it comes pre-installed with the system, right? That's a pretty good reason. And it will boot, and if you run idle, it will boot up with this. So it will say, here's Python, and it's default. Here's the top. It's running on this, like when I installed it, and it's using this information, and then it gives you this little blinking cursor, right? So idle opens up what we call a REPL, which stands for Read, Evaluate, Print Loop. In other words, it's going to read what you type in, it's going to evaluate it, it's going to print out a result, and then it's going to do it again. Read, Evaluate, Print Loop. REPL. So the first thing we typically, and we can basically use this to start with as like a glorified calculator. 2 plus 2. It'll print out 4. Right? So we can do all sorts of mathematics on it. We can do 4 times 6, right? 24. We can do 4 times 6 divided by 3, which will give me 8.0. We'll get into why it does 8.0 later. Yes? Move it over. Does it not? Oh, okay. Yep, totally. Okay. So now the way it will evaluate things via order of operations. So if I did 4 plus 2 times 3, right, that will evaluate the multiplication first, just like you would. And it will give me 10. So it will give me 2 times 3, which will give me 6 plus 4. So it works just using the same exact rules that you would use for multiplication, for addition, multiplication, and parentheses. One thing to note is that how do you do exponents in Python? And you don't use the caret operation in Python. That gives you a completely different operation. Instead, we use, and why is that? It's because computer scientists have been using this for a completely different operation for a while. So to do exponentiation, to do 4 squared, you do 4 star star 2. Right? But you can essentially use this as a pretty nice calculator, and I suggest if you're working in math or physics right now, then you might make use of Python to solve your homeworks for as much as possible. But it's not just good at working with things. We actually can write programs to execute with them. Now, the standard Hello World program is the way that things work out, is the way we start out in most programming languages. And I like it because of its simplicity. Now, in Java, which is not the programming language we use in this class, but it's the programming language that's used in a lot of classes. We do that Java in 1068. Java's a great language, but it has a bit of an issue. The programming Hello World looks like this in Java. Just to give you an idea of why I like Python. Public, hello. This is the way you do it in Java. Don't bother writing this down. Public, static, void, main. Oh, gotta make sure I spell it right. Void main, string, args. Typed this a lot of times, obviously, to have that memorized. System.out.println hello, comma, world. Now, what hello world is that it's a program that just simply prints out hello world. It's a very, very simple way to just detect that it's working. And and part of the issue when I teach Java is that I've got all this stuff that basically you have to say, it's magic, just ignore it, right? Public static, the public static void. What the heck's a void, right? What's args? You know, do we have like pirates getting hit or something? You know, so system.print line hello world, print ln short for line, right? So that will print hello world. All right, let's go ahead and write the equivalent program in Python. Okay, so to create a Python script, we go in idle, we go to new file, and I'll bring up something blank for us. I'm going to go ahead and just save it automatically in my home directory. You might want to create a folder for your Python stuff. And I'm just going to call it hello.py. It's a bit small to see. That's okay. It's not really important. I'm just giving it a name. All right? So ready for the program? Print hello. By the way, do people in the back need me to increase the text size? Do you want? Anyone? Okay. All right. Yeah, no problem. Let's go ahead and, yeah. And also, I'm quite used to programming at a very large font size because I like being able to see what I'm reading. And I don't have to like lean into my computer like that. Okay, print hello. All right, that is hello world in Python. Well, sorry, that's hello. This is hello world in Python. All right, so we save this, and then we can go to run it, and you can hit F5 or just click over here to run it over here in the Python shell. And it prints out hello world. So, and by the way, since it's in my shell, I can just, since it's a program I wrote, I can go over here to my terminal, invoke Python 3, run hello.py, and it will run that program. So this is another way I can run my program, right? It's not just available in idle. If you sent me your program, I'd be able to run it this way too. So most of the time, though, we can just work in idle. But that's it. That's all you have to do, and that's all you have to run in a program. That's all you have to do to run the program. So let me go ahead and close this. Don't save. Okay, don't need this anymore. There we go. All right, so let's go ahead and take a look at this. So what does print do? Print prints out a bunch of text. It prints out a string, okay? Specifically, it prints out whatever you put inside the parentheses. Now, if you've worked in Python, Python 2, and you might be used to doing this, right? If you're coming from Python 2, okay? In Python 3, this will give you an error, right? Missing parentheses in print. Did you mean to do that? So Python 2. So if you're coming from Python 2, you might have to change a couple of things, a couple of habits. But if you don't know Python or anything yet, don't worry about that. That was just for people who are coming in knowing things. And there's all these things over here. Don't worry about them. That's just simply hints. It's saying print out a value. Okay? So print hello world. Now, it prints out a string. A string is a bunch of text. It's literally just a bunch of text just strung together. Hello world over here. And one fun thing about Python is that, Python 3 specifically, is that it is Unicode friendly. Right? Which means that I can do stuff like this. Oh, wait, actually, I did not enable a different language. That's at my home computer. But I could take let's go ahead and turn on another language. Language support. Language, region and languages. Sorry. Import sources. There. Japanese. I don't know too much Japanese. In fact, I know about 50 words of it. But I know just about enough to do this. So I can go over here to here, and then I can switch my input source to Japanese. Let's see. No, it doesn't do that. Sorry. I have to manage install languages. Options. You know what? I'll save this for another day because if it's not working on this computer, I don't want to waste more than a minute trying to set it up. I just forget how to install it on Linux sometimes. Okay, but anyway, you can go and grab any kind of non-Unicode characters, and it will be able to handle them just fine. Like other programming languages, which will throw. They will get very upset when you try to do things that are in non-English characters. So we can put anything in here that we want to. We can put hi, my name is Andrew. You know, we can save it, we can run it, and it will run my changes. Python is case sensitive, meaning that that you're going to start hating working in word processors because word processors will try to capitalize everything for you if it begins a new sentence or a new line, right? This won't work. Lowercase, it's got to be lowercase. What other things are there? So anything else between these quotation marks get printed out. But that leads us to an interesting problem. What if I want to say, he said hello to me, right? Right? And notice that that will give us an error here, right? It says invalid syntax because what it's doing is saying, hey, we use this to begin a string, we use this to end a string, and then we have this weird hello. Is that some kind of command? I don't know what hello is, right? So how do we do this, right? Since we're using a character to have a specific meaning, but we also use that character a lot, we use something called an escape sequence, which just means we put a backslash in front of it to say, the next sequence, interpret it literally. He said hello to me. Another thing that's useful with Python that's not necessarily true of other programming languages is that instead you can just use single quotation marks for a string instead. So using single quotes, double quotes, it doesn't matter for Python. Oops, sorry. Forgot my quotation mark there. So that's pretty cool. Also, another thing over here, I said hi back. So now because I'm using single quotation marks around these things, I can use the double quotation marks inside of them, and it's able to infer, well, since we started a string with a single quotation mark, I'm going to look for a single quotation mark to end it, right? So I don't need the escape sequence there. Now, the print automatically adds a new line character to the end of everything, right? It automatically advances it to the next line, right? It doesn't just simply just glue the strings together. And that's actually a character you can use by using another escape sequence. /n translates into the character as a new line character, meaning that it will advance us to the next line. Okay. And let's see. Another interesting character you can use is one that we don't get to use too much in terms of visibility, right? We don't see it a lot, but we use it plenty, and that's the tab character, the /t, right? And tab will just simply indent the things based on how big that is. So for your escape sequences, there's only a couple to know, 4 specifically. There's the / quotation mark for getting you a quotation mark. /n gets you a new line. /t gets you a tab. And then finally, if you want to print out that backslash character, since we're actually, using it to print out a quotation mark, since we use that to escape stuff, to print out an actual backslash, you have to do 2 backslashes to get a single one to print out. Because remember, the backslash says the next thing is a escape sequence, right? So that's how most things work in Python in terms of text. Now we'll have another. So this leads in very well to our next to the homework that you'll be doing in lab this week. The purpose of the lab, by the way, is to get Python set up and running in on your computer. It's going to be a 2-part homework. 20 points for doing Hello World, and then I want 80 points will be doing ASCII art, which you may have seen at some point. So ASCII art is something that was done when basically when graphics were pretty limited. Right, here we go. ASCII art, a tank and a truck made using ASCII art. And you can see that basically the tank is made up of it's made up of different types of characters, equal signs, brackets together, at signs for the wheels, right? And it comes back from like using stuff like this, like it has actual, you know, art backgrounds for it. So it's actually pretty interesting where it comes from. But you know, in days where basically text was the only way to get things apart, if you wanted to send pictures or you wanted to draw a picture, then the only way you could really do it was to basically use a bit of ASCII. Or if you wanted to do some embroidery for your username or your signature, you needed some of this stuff. Right? So here's some cats. Here's the Wikipedia symbol. And then you don't necessarily have to use just ASCII because, again, ASCII is these basic 128 characters that were originally specified for computers. And then you'd have 256 that were another 128 that to make a total of 256 that were language dependent. However, this led to a lot of issues, like French would use those last that last 128 characters for one thing, Greek would use it for another. And, you know, if you're Chinese or Japanese, you'd be banging your head against the keyboard because those characters aren't nearly enough to fill your alphabets or what amounts to them. So, you know, because, you know, I don't know how many Mandarin characters there are in Chinese, but there's a lot in standard Chinese. And there's, you know, I think there's like 2,000 official kanji in Japanese, so it's just not enough. But so you can use stuff with Japanese characters if you want to create different things. But that's your first assignment, and that can be as intricate or as simple as you want it to be. It's just simply a simple way to get you guys comfortable with print statements. The one thing I should mention is that you are about to become very into fonts, possibly. I'm using a monospaced font, and you by default will be using a monospaced font. And this is very important. Monospaced fonts mean that basically that each character takes up the exact same amount of space. This quotation mark takes up the exact same amount of space as the I symbol here does. And this is very important for making sure things are lined up properly. And that's very important in Python because Python's all about lining things up properly to tell what belongs to what, right? If I were to use something like, let's see, if I were to just use Noto Sans, which is a, you know, that's a font, that's a regular font, right? Things don't will, you know, stop lining up properly. You know, the I is smaller than the H, right? And that will make it harder for it to line up. So you want a clear, legible font for that to be used. I use Fira Code, which has some interesting properties, as you'll see. But you can use whatever you guys feel good about. For Macs, you know, the San Francisco-based fonts are pretty good. On Windows, the Consolas font is way better than the Courier New font that's typically used as the default. So find something that you find aesthetically pleasing, you know, and use it. But I particularly like this font because of ligatures. So I don't know if it works in here though. No, it doesn't look like ligatures work in idle. So I might be using a different editor. But as you'll see, it will be very useful to use a monospace font. All right, so this class goes up to what time? 2:50? 3:20. Oh, I've got plenty more time. Okay, I started at 2. Oh, okay. Yeah, plenty more time. Okay. Okay. I was worried where all that, I was thinking to myself, where has that time gone? Okay. So let's go ahead and, you know, see some basic ASCII art, and we'll see why I mentioned that it's very useful to do stuff. So let's go ahead and write a basic thing, and I'm going to start by drawing maybe like, you know, a basic triangle. Okay. So print space slash, and then to print out a slash like this in this direction, right, I have to use 2 slashes. right? And then print, right? Slash slash over here, because I need one more over there. And then let's go ahead and do print. Right? And let's see what we've got so far. I'll call this ASCII.py for short, and I'll go ahead and run it. Right? Oh, it's a bit jagged. And that's probably because I used, I misjudged the spacing. There we go. Right? And it prints out 1 because this you need an escape sequence to print out a backslash. Let's go ahead and now I could do something like this to give it a base, right? But it's pretty simple to draw stuff like that. One thing that you'll be commonly doing is copying and pasting, by the way. So get used to doing that, right? If I wanted to just simply stack these things, I can just simply copy and paste, right? Kind of like that. Okay. Right, not too bad about that. Copying and pasting is pretty straightforward. But one of the abilities of programming languages is the ability to define new commands. Because copying and pasting is a bit boring. It's not fun to do. So we can create new commands pretty simple, in a pretty simple manner. We can say def, and notice that lit up in a different color. This is called syntax highlighting. It's a very useful feature. Def print triangle. So def is short for define function, and it basically means that I want to define a function. Right now we'll leave this blank, and we use a colon to kind of define to say what goes inside of this over here. And let's go over here. Print, doop, and then I will put these over here. Okay, just making sure it compiles. All right. So what this is that I've defined a new function, and it is a new command for the programming language to use, and it is called print triangle. And then you end it with a open parentheses, a close parentheses, and a colon. We will use these parentheses later to define what are called arguments or parameters. In other words, to feed in information to a subroutine or a subprogram. And then basically it will when you run print triangle, it will execute whatever's inside of print triangle. How do we know what's inside of it? In Python, we use indentation. We use the white space. In other programming languages like Java, it uses curly braces to define that. But in Python, we just simply say, oh, it's inside the function if it's indented to the side, right? It knows that these three things are inside print triangle because they're literally underneath it, inside of it. That makes sense to everybody? So now, if I were to run this, I can type print triangle, open parentheses, close parentheses, run it, and it will print a triangle. And then I can just simply copy this line, right? And this will print 5 of these things, which is pretty useful because now I can define a whole lot of other shapes. Print square. All right, squares are pretty simple to draw. And it's very useful and already has indented for me. So let's go ahead, create a square, and we'll just start by doing 6 across, right? Which of course means that it will need to be 6 down, so that'll be 6 print line statements. The bottom should probably be the same as the top, so I'll just copy that over there. And in the middle, I will, just use this pipe symbol. That's now the pipe symbol that I'm using, that's above your enter key. It's the backslash but with the shift. And congratulations, you are now one of the few people who will actually be using it, because I've never seen anybody but programmers need to use these things. Now, sometimes your indentation will get messed up. In Python, it is very important that that indentation does not get mixed up. So let's go over there and do print triangle, print square. And, you know, the horizontal spacing and the vertical spacing isn't, you know, it isn't precise the same. Looks more like a tube, right? But that's okay. So maybe I'll call, so you can always change the name of these things. Print tube. You just got to be sure to change the name over here, because if you try to use a command, it will say error, in line 16, print square is not defined, meaning I'm trying to call a function that doesn't exist, right? What is line 16? Do I actually have to manually count it? No, most text editors will have the lines right over here. Python, sorry, completely forgot that this, right? Okay, Python on the other hand, or idle at least, has the line number right here in this lower corner. So I can just change this to print tube, and we're back in business. So then, we can get that. Now, what's also really cool is that I can use these commands that I define. I can use them to call commands I've already defined. Let's see. Print rocket. Print triangle. And then print square. And then I'll just copy this a few times. And print triangle. It isn't exactly the most, you know, exciting stuff we're doing here, and I apologize for that. But, oh, sorry about these semicolons here. That's just a bad habit from Java. So that's just me doing that. It won't affect the program, but that's just simply a habit from that. You need a colon. This is a colon over here as opposed to a semicolon. Yes?
I think you need print tube rather than square.
Oh, yes, print tube. Control find. Find square. Let's see, do I have a replace? Another fun thing we'll be using here that will be useful is the find replace function. And we'll be learning regular expressions in this class, because we have time to learn regular expressions, and you should learn regular expressions. So there we go. That did not print tube. Oh, right. And so now over here I can do, right, the function won't do anything unless you call it. So now I can do print rocket. Triangle. Thank you. There we go. And now we've got a basic rocket. You know, nothing too fancy there, but you can break these programs down into smaller and small subprograms, which is a really nice feature of Python and other programming languages. We'll get more into that later. But for now, I want to turn back into the interpreter. So that's one. If you find yourself having trouble organizing stuff, organize it by creating new functions. So let's go ahead and open up our interpreter again. Okay. And the nice thing about doing stuff in a scripting language rather than the nice thing about doing things over here in this script over here is that you can save it and load it, right? Doing stuff in the shell over here, it won't be saved, right? So a common mistake that I see from students doing this for the first time is that they do their program in here and then they just copy and paste it, copy and paste this output and turn that in. That's not what I want. I want you to turn in a script for most of these programs. But using the shell is pretty useful. Now, how does this work anyway? I type like print, spam, and it will print spam, right? How does this work? Well, Python is what we call an interpreted programming language, meaning that the rules are pretty light and fast. And what it does is that there's this program running called an interpreter. That's this right over here that's telling me it's running. And it translates the commands it's a program written specifically for your computer, and it translates the commands that I give it into the machine code, the binary zeros and ones that your computer needs to execute it. And that's fairly straightforward as things are concerned. So let's take a look at what else we can do with these things. Well, I already mentioned that we can use these for, just doing basic mathematics. But we can also store things in variables, which is fairly simple. We can go x is equal to 5, and that will store x. That will store 5 in x. Right? I just simply type x, and it prints out 5. So it's pretty cool. So now we can start doing interesting things. Now I can't do 2x. It will give me a syntax error. But I can do 2 times x, right, which will give me 10. That's pretty nice too. I can also do y is equal to 3, and I can type x times y, and I can get 15, right? Now, what's important to note, and I'll re-emphasize this again and again throughout the semester, is that what happens is that the thing on the right gets stored in the variable on the left. We evaluate what's on the right, we evaluate the expression on the right, and we store it on the variable on the left. This equal sign is not the equal sign you think it is. It's actually the assignment operator, right? And it's much better viewed as this, right? Y is equal to is not that, but rather left arrow 3. We're taking a 3 and we're storing it in y. Now, why don't we use this notation? Well, I'm going to read it as y is less than negative 3. That's why, right? I can read that as y is negative 3. So the arrow won't work. So some programming languages then did something that looked a bit similar to an arrow, which was like colon equals, which just eventually gets shortened to equals. So we just simply use it because we say, so we can say y, that 3 gets stored in y, right? And then I can update this value. I can say y is equal to, x, right? So now x is 5, y is 5, and now I can say, and what's important to note here is that everybody just got their own copy, right? We took the value 5 and stored it in x and stored it in y. So if I do x is equal to, and this gets into stuff that we'll be covering a lot again later, x plus 1. That's something we can do here. Now, what does this mean? We take the expression on the right, we evaluate it, and store it on the left. And this looks scary. Don't worry. We're going to do this a lot of times through the semester so that it becomes much less scary. So we take the value on the right, and we store it on the variable on the right. So x is what? It's 5. We add 1 to it. It becomes 6. Again. X is, so we take 5, we add 1 to it, it becomes 6, and then we store 6 in x. Whoops, I just simply deleted that. X is equal to x plus 1. There we go, because I was highlighting it and hit enter, right? So that replaced everything I had typed with an enter. Okay, x is equal to x plus 1. Let's go ahead and see what x is. It is 6 now. What is y? It is 5, because y got the value of 5, right? So the way the programming language works, just, again, it's a grammar, it's a language. You're going to just have to get used to the way it works. But these expressions are very, very powerful and make it able so that you can, store things in there. That's a pretty good place to start talking about data types. What kind of data is there? There's a few different types of data in basic types of data. What we've been dealing with now are what we call integer types. Now, in other programming languages like Java, we'd have to say, like, oh, an int has 32 bits, which means it has a maximum value of 2 billion and a bit. Or maybe it's a long, which means it has a maximum value of 2 to the 63rd minus 1, or a minimum value of negative 2 to the 63rd, right? Python says a number's a number, and we don't care how big it is. We'll just simply store it. That's very useful for us because let's see. Python just does not care how big a value a number is. X is 5 to the 1242nd power. It does not care how big the values are. So these are what we call, now again, we're dealing with what are called integer types, integral types. These mean that these are specifically whole numbers, your integers, right? 1, 2, 3, 4, and also, you know, we can totally make these things -2, right? X is equal to, so X times -1, right? Negative, that huge ginormous number, right? But these are integer types, meaning they don't have a floating point. Now, in Java and other programming languages, you know, this would cause an error. Python just simply does not care how big it gets. It will get it to it will just simply try to hold it as best it can. Now, it may eventually take a while for you to print out that number, but it will hold that number for you. There's also other types of numbers, your doubles or floating point numbers. They're called doubles because the type is double in other programming languages. In Python, they're better called floating point numbers, and they're anything that has a decimal point in it, 3.0. And they work almost exactly, precisely the way you think they should. Almost exactly likely. However, we are dealing with a base 2 system here, right? Right. Most of the time, we deal with stuff in a base. We work in a base 10 system, which means that we can't always encode numbers properly. Like, right? If I'm doing 1/3, right? What is that on a calculator? It's 0 point a bunch of 3s, right? Right? Because I can't properly encode that infinite sequence in a base 10 system, right? I can't encode that in a base 10 system because there's always that extra three that's just repeating. And so the computer just tries the best it can. Similarly for 2/3, just as many 6s as possible. So there are occasionally weird things that can happen that you're probably never going to see outside of this example because of that, right? When we're converting base 1 numbers to base 10 numbers to base 2 numbers. So 0.1 plus 0.2 should be 0.3, and this will be the same as in any other programming language, by the way, because of the way floating point numbers work. It's not 0.3, it's 0.3 and this weird little bit over here. And there's this whole discussion on Stack Overflow as to why it's going to happen. And it has to do, again, with just trying to convert these base 10 numbers to base 2 numbers. It can happen. But these numbers are as precise as possible, and they're as precise as you care for significant figures. Okay? Which is an important thing there, right? If you're trying to get 10 sig figs in, it's going to be 10 sig figs, right? It's a good number of significant figures in there. Right, so it's not something to worry about most of the time, but it can happen. It's rare, but it can happen because of just the way numbers can get encoded. But for most of the time, it's just not going to be a problem. 0.1 times 2. It's going to give you 2.0, right? That, again, you're probably never going to encounter that outside of what I just did there. It's a contrived example. Now, floating point numbers and integers don't exactly mix. 4 plus 4.5. What happens in this case, though, because they technically don't mix, is that 4 gets translated into a 4.0, and so we get 8.5. In other words, Python will seamlessly convert them for you, so you don't actually have to think about it. Now, in other programming languages, also, if you're coming from C or something, so for those of you who have taken C or Java, what is 1 divided by 3 in Java or C? It's 0, right? Because in Java, what we do is integer division. We do 1 divided by 3. What is the quotient of that in 4th grade? It's 0, and the remainder would be 1, right? It would be 0 remainder 1, because it's dealing with integers. How many times can 3 go into 1? It can go in precisely 0 times in terms of integers. Now, Python thought that's really unintuitive, So we're going to just simply do, if we do any kind of division, it's going to work the way we'd expect a calculator to do it. Okay? So it will do 1 divided by 3, and it will convert them both to floating point numbers and give you that answer. Right? If, however, you want to do 4th grade arithmetic, and this is way more useful than you think it might be, if you want to go back to 4th grade and do 4th grade arithmetic, you can do 1//3, and that will do integer division. Now, why in the world would I want to do this? Well, if I want to divide a number by 10 and or throw out the last digit of a number, I can just simply do integer division by 10, and it will just throw out that last digit, which is pretty useful. If I want to just simply get the first digit of a 4-digit number, I can just simply do that and divide by 1,000, and it will give me just that first digit. This may come up in a homework in a couple of weeks. And by may, I mean it will totally come up in a homework in a couple of weeks. So there's a number of useful tricks there. So if you want to just get the quotient, you can use division. There's also one more mathematical operator that we use. So there was plus, minus, there was multiply, and then we had divide, and we also have integer division, right? There's one more mathematical operator, and you may think it's the percentage sign, and it's not in terms of Python. This is the modulo symbol. And now there's all these weird, scary things that happen with modular arithmetic, and it's like there's like advanced group theory mathematics that are behind it, or set theory stuff. It's not actually that scary. All this means is that I want the remainder when I do division. So 5 modulo 2, what is the remainder when 5 is divided by 2? It's 1, right? 5 divided by 2 gives me, it goes in twice, right? 5 divided by 2 will do in 4th grade would give me 2 remainder 1, right? Everybody remember doing long division in 4th grade or whenever you learned it, right? So modulo gives you the remainder, which is also a very useful thing, right? Like for instance, when we do division by 2, we can tell whether something is even or odd by using modulo. Again, something we'll come up with there. So modulo is pretty useful. An artifact of this, a very useful artifact, going back to our example of like throwing out, right? We could do divide by 10, integer divide by 10 to get to get 130. But if we do mod by 10, we get the last digit, right? Which is pretty useful. So there's a lot of useful things there. Now there's other types of operations, but those are your numbers. You have your integer numbers and your floating point numbers. Now there's also, as we talked about, there's strings. Hello, right? Nothing too much like that. And we can also just simply put a string there. By the way, you're not limited to just using one letter for a variable like you are in mathematics, nor should you, right? Word is equal to hello. Okay? Now, strings can actually do some operations. So if I said word plus space world, interesting thing here. This plus sign is now what we call a concatenation operation, meaning it will glue hello and world together. Right? So strings, when we do addition with strings, it acts like a glue. So 1 plus word, by the way, oh, I need a plus sign. 1 plus word, int and string don't match. So that would work in Java, just FYI, which is why I tried it. Can I do word plus 1? No, you can't add those. You can't add them together. But you can convert things into a string pretty easily. Word plus str1, we'll turn that into a string. So you can throw the str and parentheses around anything to turn it into a string. And yes, I know there's a lot of information coming at you really fast. Well, that's because Python's a pretty easy language to know. Again, all you need to know for the first week is just simply how to do the use the print statements. So you can do addition with strings, and strings add to strings, but not anything else, unless we turn it into a string, which is something we'll get into later. Okay? So word plus, so let's see, word is hello. And you can add it to other strings. By the way, can we subtract it? Can we do hello minus LO? I mean, intuitively, you'd think, okay, just simply snatch off the LO from there. But actually, minus is not a defined operation for string in string, it says. What about multiplication? Interestingly enough, and one of the reasons I do love Python is, and this is the last operation I'll give you for today, is that you can actually multiply strings by an integer and do hello, 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 hello. Right, and that makes sense, right? If I'd like to do a string 5 times, I can multiply it by 5. All right, so what have we learned today? We've learned about installing Python by going into the Python website. We learned about idle, which has 2 modes. One, which is this REPL mode, which is very useful for teaching. And the other way, which is going to be the way we do our homework most of the time, which is the scripting which is the script. We learned how to use the print function. We learned how to use the routines. We learned how to do functions. Right? We learned how to write our own functions. We learned how to use escape sequences. And we learned that there's 3 primary data types. There's actually a 4th one we'll get to called the Boolean data types. But there's ints, floating point numbers, so ints, floats, and strings. All right. If you need to come and speak to me, come down here because I'm sure some of you have individual needs and questions.